All right, this is my last attempt. If it drops again, I'm just going to switch over to recording. It looks like it's actually working though. Do keep me posted on Piazza. If it happens again, we'll just have to switch over to a recording. Sorry about that. I'll talk to IATS about yet again the internet's here. Okay, so back to the code here. I don't know how much was cut off at the end. So just to update you here, we're not only keeping track of the array, we're keeping track of the size of the array. Initially, that's going to be 0. And if there's one thing in there, then the next thing that we want to put in is at index 1. If there's two things in there, then the next index that we want to put that in is at 2. So in general, we want to put it in at the size. If the size is 0, that's putting it at the front. If the size is 1, that's putting it at index 2, or at the second index, et cetera, et cetera. What else should I do here if I'm adding an element to my list? If I'm now keeping track of the size? This dot size plus plus. Right? Add 1 to the size. Excellent. Also, if I'm keeping track of the size, wouldn't it be nice to tell the outside world how many things are in this list? Right? Because if the outside world wants to iterate over them, by, say, index. I want the first element, and the second element, and the third element. The outside world has to know how many elements are in there, right? So let's go ahead and add a public int getSize method. Right? And we'll just simply return this dot size. Right? So that I know how many elements are in there. Okay. Also, I probably want to know what elements are in there. I want to, just for debugging purposes and demonstration purposes here, I probably also want to maybe print out the list, right? That would seem like a convenient thing to do. So public toString. I'm going to go ahead and use the built-in toString method to do this so that I don't have to explicitly convert this list to a string for me so I can print it out, right? That's the whole purpose of having a toString method. And I'm going to do this using a for loop here. For int I equals 0, I is less than this.array.length. Does that sound right? Should I iterate over every element in the array? No, remember, it has a capacity of 10. I add 1 element to it, 2 elements to it, 3 elements to it. I only want to print out those 3 elements. Okay? So, let me go ahead and create a string builder here. String builder SB is equal to new string builder. And then we'll append this dot array of I. And then we'll also append a comma here. We won't get too fancy. There will be a trailing comma there. But what do I want to go up to instead of array.length? This dot size. You've only put 3 things in there. I'm only going to go 0, 1, 2. Okay? And then we'll return this, or sb.toString. Okay. It's happy about everything in here for so far with my first version of this. Let's now go over here and actually start using it and testing it. L.add_to_end 10. L.add_to_end 20 and 30. So when I print this out, system.out.println L, then I should have 10, 20, 30. And works. Again, I have a trailing comma here. I'm not going to worry about that. Right? Okay, let's go ahead and test this a little bit more. I want to add 10, 20, 30, 40, all the way up to 150 or something. For int I equals 10, I is less than or equal to 150, I plus equals 10. I'll just go by increments of 10 automatically. L.add_to_end, the integer I. Right. Ah, it failed. Why? I only had a capacity of 10, right? And I tried to add 15 things to it. Index out of bounds exception. Index 10 is out of bounds for length 10. Wait a second. This is my world over here. Do you see me using an array anywhere? No. So this is a leak. This is one of those leaky abstractions. This error message has leaked the fact that inside that list, I am using an array to represent the elements and store the elements. We don't want that. First of all, we don't want it to error out at all, right? We want to automatically dynamically grow or shrink, based on there are 10 elements in there. You give me the 11th element. Okay, I'm going to go ahead and expand that out for you. So let's go ahead and go back to our add to end, and let's make a check here. What should I be checking? If it's full, right? Now, internally, if it's full. I could design lists that have a maximum size. You can add no more than 50,000 elements to this thing. Doesn't seem that useful, though, right? That's an arbitrary number. I just pulled that out of the air. Maybe there's some sensible memory limit or something like that. But in any case, if it's full, internally it's full, I need to expand it out. So how can I do that? How can I check that? List, or the array is full, ... If this dot size is equal to this dot array dot length, right? If there are 10 elements in there and the array has a capacity of 10, then we're full. We need to expand it. Expand the array. Now, can we do that? No, that's the whole purpose of doing this list, is that an array by itself cannot be expanded. So what we can do is this is our old array. We can create a new array that is bigger. And then we can copy things over, and now we've got additional capacity. Right? So an array of size 20, or an array of size 30, right? And it'll grow automatically in increments that we can then tune and specify. The array is full, so let's expand the array. What I'll do is I'll create a new array, integer array, new array. I can't call it new because that's a keyword in Java. And I'll equals a new integer array of size 10, or should I go 20 now, right? I want a bigger one. Right? What happens when I reach a capacity of 20? Do I create one that's 20 again? No. So this dot array dot length, and then I'll add capacity for 10 more. Right? And then I will copy over the current elements. For int I equals 0, I is less than, I already know that it's full, so array dot length I plus plus. The new array will take on, at the ith index, it'll take on the value at this dot array of I. There we go. So I've copied over all those elements. And then, am I done? Remember, I've got this new array over here, and I've got this object's array. I'm pointing to two different arrays. Here's a capacity of 10, here's a capacity of 20. What do I want to do? I want to make the object's array reference point to this new array. This dot array is equal to the new array. Right? That is a shallow copy, but it's okay because I'm only changing the reference. What about that old array? What happens? In C, you would have to clean that up. You would have to call malloc, or if you call malloc, you eventually have to call free. If you don't, then you have a memory leak. Do we have a memory leak in Java? Nope. It manages our memory for us, so we don't have to worry about it. Excellent. What about the rest of it? This dot size, there were 10 elements in there before. Where should the new one go in the new array? At index 10. We don't have to change any of that stuff. Right? We've already expanded it out and copied it over. Right? So let's try this again over here in demo and see what we get. Excellent. We didn't have to worry about any of those little details. Right? Abstraction, encapsulation, working together here so that we don't have to worry about it. Right? I can go all the way up to 1500 if I really want to. And it'll expand in increments of 10, 10, 10, 10 each time. There is a cost, right? Copying everything over, every time you want to expand it by 10, there's a cost associated with that. We'll talk about that cost when we get into algorithms and algorithm analysis, right? But I'm going to go ahead and ratchet it down here to just 15 elements because I want to make sure that it works, okay? Okay, now what? What else do we want? Oh, we have a way to add things. What about a way to retrieve things? Put stuff in, you can never get stuff out. Doesn't seem like a useful data structure to me. So let's retrieve things. I already have a way of doing that with the toString method, but it's not that helpful because it converts it to a string, and now I'm stuck with a string instead of a bunch of integers. So let's go ahead and make another function here. Public. What should it return? I'll call it getElement. Right? So if it's called getElement, you want the element, I give it to you. What's the element? It's an integer. Good. Now, before we move on here, what if I gave you an integer array, and then I just simply said return this dot array? Get all elements. Right? It kind of defeats the purpose of designing a list, right? Why do you want to, if you wanted an array, just make your own array. Why am I holding on to that and then giving you the array back? I'm a list. I take care of all that stuff for you, right? You shouldn't have to worry about that. So not get all elements, get an element. How do you want to get an element? What if I wanted 10, right? If I wanted 100, if I wanted 150, right? I want an arbitrary element, so I can make this index-based. Get element at index, right? So what I need is, which element do you want? I want an index. I want the element at the index. You have to give me the index. I go, okay, here it is for you. Here you go. It's still going to be zero-based because that's what people are familiar with, right? The only thing that's not zero-based is MATLAB and, unfortunately, JDBC. Right? All right. So I can simply return this dot array at that particular index. Right? Neat. It works. Over here, let me use it. Int x is equal to L dot get element at index. I don't know, 10, the 11th element, remember, because it's 0 indexed. Well, let's go ahead and print that out. Okay. What should that be? Predict. If I start at 10, what's the 11th element? 111, right? That's why I made them in increments of 10. Oh, 110, sorry, not 111, right? Okay. Get element at index 15. What should that be? 150. Oh, no, it's not. There isn't one, all right? This is at index 14, remember? Because it's 0 indexed, but we start at 10. So 14 would be the last element, right? There we go. And 15 would be one beyond. And that's a null pointer exception. Actually, actually, that's weird. Why is that a null pointer exception and not... oh, I know why it's a null pointer exception. Don't worry about it right now. Right? Instead of index out of bounds exception is what I expected, right? Because there is no... Oh, yeah, why? Why did I get a null pointer exception when I asked for the element at index 15? I only put in 15 elements, but the capacity was 20. Here it is. What is it? Null. When you try to print it out, it's null, right? So it's not. It's not even the right kind of error message because of this leaky abstraction that I'm kind of leaking out the information that there's extra capacity here that you don't know about. You get a null pointer exception instead of an index out of bounds exception. If I did an index out, if I did something at index 150, certainly there's going to be an index out of bounds exception because the capacity is only 20. That's way beyond 20, right? Okay, fine. I'll check. If, here's my index, int